In this tutorial, we will see how to use the NiLAB Starter motion controller. The first step is to establish a connection via the USB Modbus RTU interface. This can be done using our programming box, or a simple USB to Modbus cable, making sure to select the correct port, in this case, COM10, with a baud rate of 115,200. Once connected, the data is uploaded from the motor. In this example, we have preloaded a motion sequence between 2 points, where the trigger is generated by digital input number 1. The table is currently configured to emulate a pneumatic cylinder. Input 1 acts as a level signal, similar to a solenoid valve control. So position 0 corresponds to a low signal, while position 1 activates when the signal is high. Specifically, the motion table allows you to program up to 10 different positions. In the first column, we define the motion profile. Here we have chosen the polynomial profile, but you can also select trapezoidal, triangular, or sinusoidal profiles. The table also offers 2 other options: the force profile, where the motor pushes with a specific intensity for a set time, and a profile managed via an external digital input in pulse train mode. Before defining the positions, we must reset the motor position through the homing procedure. We have 2 options. Auto homing, where the motor moves and zeroes itself against a mechanical limit, or manual homing, where we manually move the motor rod to the 0 position. In our case, we will press the auto homing button. The motor will move to the mechanical stop with the direction and speed defined in the parameter folder. Once complete, the current position will become the first position indicated in the table. Now we can proceed to configure our motion table. We'll keep the polynomial profile and move to the second column, which defines the target position. This can be entered manually or acquired directly through self-learning. For example, by clicking on the RAW for position 0, we can move the axis, and by pressing the Teach button, define the first movement point. Next, we set the motion time. Since this is a polynomial profile, only one parameter is required, unlike trapezoidal or triangular profiles which require more. In this case, we define a motion time and a dwell time, keeping in mind that all times are expressed in milliseconds. To simulate the cycle without external signals, we set this row to automatic mode. We then proceed to the second row by defining a new position, again using the Teach button, and set the same motion and dwell times as the previous row. After setting this row to automatic as well, we download the new configuration to the motor with the Download to Drive button. To test the system, simply enable the motor by pressing the ON button and then the Start Motion button. Remember that all changes can be made while the motor is running. If we want to increase the motion time of the first step, we simply enter the new value and download it to the motor to see it updated in real time. The same applies to profiles and dwell times for every row. If instead we want to modify the movement speed based on cycles per minute, we can use the motion task wizard located to the right of the table. The first step is to minimize the dwell time, and using the plus and minus buttons, increase the desired number of movements per minute. After selecting the current motion profile, and pressing Set Motion Task for the automatic recalculation of parameters, we download the data by pressing Download to Drive. The system is now moving with the new cycles per minute value, but we can increase the speed further by simply updating the values, pressing Set Motion Task again, and then downloading them. Finally, if we want to add an intermediate point, we stop the motion, disable the motor, and move to row number 3. We acquire the new point via self-learning and define the relative times. After setting the automatic trigger and downloading the data, we re-enable the motor and press Start Motion to run the complete cycle across the 3 positions. Remember to then redefine the trigger mode via the external signal on digital input 1 to control the motor through your PLC. To control the motor via an external PLC without using NiLAB Starter, you must enable the I/O control functionality in parameter 4097. The standard configuration of parameter 4096 for digital output 2 provides the in-position signal, which the PLC can use as confirmation that the position has been reached. To define the validation window for this signal, you must modify parameter 183. Lastly, remember that any configuration downloaded must be permanently stored by going to the parameter folder while the drive is disabled and pressing the right configuration to flash button.